And like we are live. All right. Let's see the chat. See the chat window. Anyone here? I think nobody's here yet. It's 4 o'clock already, right? Cool. All right. I need to. We'll leave it to this side. And let me see. All right. Sorry, it's been a very busy day today. So, I'm here. I'm here like every Learn Day. So it's not Monday, it's not Tuesday, it's Learn Day. Cool. And today, we're gonna learn something really cool. Fracturing. That's cool. Fracturing is pretty awesome. And you guys been asking for it, so just let's just give a few minutes for people to get here. Just gonna open Houdini. Let me see, where's my webinar? I'm gonna make a new project for this. In my webinars folder, webinars, here, I'm gonna call it fracturing, yeah, fracturing basics. All right. Okay, we're set up. Hey guys, hey Dennis, hey David. So, getting into fracturing today. So, all right. So let's. The first thing that you wanna see is what help can we get from Houdini, right? So let's go to the help. But that's not the help. Content. And let's search for fracturing maybe. Fracturing, there should be a few things. Auto fracturing, debris, fracture examples, which is pretty cool. There's examples for this. Shattering, all those things are pretty amazing. Fracture solid objects. There's a few ways to fracture stuff. So auto fracturing, there's a few examples. Let's see, what example do we have here? Let's see, fracturing again. Fracturing. Fracture examples. Yeah, there's a few examples of the Bornoi. Let's load that. Let's see what did we have there. It's a really nice way to start, always just trying to see if Houdini has an example of what we're trying to do. That's had solved some issues for me sometimes, or some problems that I wanted to, projects that I wanted to do. In the examples, there's sometimes there's always something there. And they are pretty helpful. So you can see this is something that it's been fractured. And inside we have notes, and there's all sorts of examples here, which is pretty cool. Let's see the next one. I have no idea what this is. Yeah, it's fracturing when it collides there. It's dynamic fracturing, velocity transferring. Let's see, yeah, the examples are pretty cool. Yeah, that's pretty basic stuff. Well, it's not basic, but Houdini makes it so cool. Makes it so simple. Let's see what else do we have here, which is this new piece properties. Yeah, I've seen this one. This is the screwdriver. Just goes pretty fast and crashes against the wall, which is pretty cool. I guess the pieces on the ground break. Yeah, that piece broke in there. Glue fracture. Yeah, glue is so cool to use for fracturing pieces. See what's happening here. Some pieces are glued until they just collide with something and start breaking apart. Pretty cool. Compound object. I don't really know what this is, but I think it's several pieces of an object. Several pieces make up an object. Yeah, it's pretty cool as well. So these shares just collide in there. Looks pretty damn cool. Tell me. Just turn on. Yep, that looks pretty cool. Let's see what else. So you can see there's a really nice sort of examples here. Cool. So this could be something like an explosion, that it's something that's making explode these objects. If we hide that object here, we hide it, you can see it's kind of making those pieces explode there. Could be something like the shockwave of an explosion, or gun, or cannon, something like that. Pretty cool. Yep, that's pretty damn cool. So yeah, a lot of people ask me about, can I do this, can you do that, and some examples are already there. Like this building thing, people have been asking this forever, and there's already an example there. See, there's an example of a building collapse. It's already in Houdini, so you just have to take a look at and see what Houdini already has, and just look around, see what the artist did, and just take what you want to use from this and adapt it to your project, which is pretty much which is really useful actually. Just take whatever there is and start adapting it for your projects. Pretty cool. All right, but yeah, I didn't even knew that this building was here, and this is something that people have been asking me a lot to do, like do the building destruction, build the destruction. This is one example. And as I did in my latest Monday tip, I show you how to read the scenes, so you know, excuse me, so you know exactly how to open an example and see exactly what the artist did at each and every step. So Houdini doesn't hide anything at all. So you can see this is a great example. It's a great starting point for any project. See, there's some force here at the beginning that is just exploding that, which is this geometry there. You can hide it and just see that it's just collapsing the base, and some other areas are already broken. Oh no, yeah, it gets broken when that explosion triggers, and it's doing the fracturing here dynamically. It's pretty cool. It's not pre-broken. If you just move the explosion to somewhere else, it just everything will behave differently. All right, so that's that's pretty cool. That's pretty cool that you can just get this stuff already inside Houdini, and there's a ton of examples. There's a ton. All right, so let's start understanding this, because it's pretty cool to have an example and adapt it to what you need. But it's a totally different thing to actually understand what's happening. Let me just check something here. Velocity transfer, rigid body solver. Oh, it's just an RBD. That's why it's so slow. Let's put it to bullet. I was wondering why it was so slow, but yeah, That is something that the bullet solver does sometimes. Just kind of explodes a little bit. You can compensate for that, but yeah, that was one instance that you could use the RBD solver. All right, so let's make a new scene from scratch and let's start understanding what happens here. So the way the Houdini fractures geometry at the moment, it's by using a Voronoi method or pattern. So we can see it actually. Let's go to the images. Let me create a image network here. There is it I think there is a Voronoi generation here. Voronoi noise, there we go. Let's plug it to the I always get confused by this. Let's plug it the distance to the R, but I need the position, the X value, I think. No, I always get this wrong. Let me just remove that. This should be 3D noise and frequency. Let's do it in let's do it in a shader because that's simpler. So let's do a material filter. Just gonna plug a Voronoi noise here. The position is gonna be just the position, and let's connect that to there. Let's put a that shader to this grid, or we can actually use the shader view maybe. Let's see if it shows here. So let's just select that pop material here, and it's not working. Grid, or maybe it's working. I think it's working, but my shading abilities might be wrong. Let's try to render this. Let's put it like this and create a simple camera. Let's move it up like this. And did I just reset the camera? Why did I do that? Assign the material to that guy. Here we go. Let's just render this. So we're getting, and that's what we're getting. That's pretty cool. That's what I wanted to get. So there's this cells there. Do I really need the position? Yeah, I do need it. Let me see if there's something better here that illustrates this better. All right, that's the one I wanted. So let's make the frequency lower. I mean bigger. Yeah, the position, it's not helping. Frequency 1, frequency position set. Yeah, position is okay for now. Or you can connect the camera actually. That is not working. Let's put the position. All right, so we have these cells in the Voronoi generator there. And these cells represent, like, let's think about this like if they were bubbles. Let's make this maybe bigger. You can see we have like 1, 2, 3, 4, 5, 6, like 6 pieces here. Let me make it smaller, maybe. Try to make it smaller. We have like 1, 2, 3, 4, 5, 6 pieces here. So what's happening here to generate this? It's scattering points to the surface. Like one point is here and here, and another one's here, another one's here, and then it starts expanding that point towards the nearest cells. Sorry, and then it starts expanding like a circle. Then when it crashes or collides with other objects or other cells, it just starts flattening until it just makes all these shapes. And if you haven't, there's just remember that Pixar in a box. There's a class in the Khan Academy about Pixar in a box. And this is pretty amazing. If in the patterns, in the pattern section, you can see this is what I'm trying to explain right now. This is how the Voronoi actually gets generated. So let me open this image bigger. This is what's happening. It gets points at every center of the cell, scatter points, and then expands those points, and then it makes this pattern at the end. So this is what's happening with the Voronoi. This is exactly what is happening, and I really recommend that you see this class about patterns or all the material here from Pixar in a box. It's really amazing. But especially for this, there's a few classes here that explain the Voronoi partition. It's pretty cool, and this is exactly what's happening here to generate that. So now that we know that this is what it's actually happening, you can see that actually if I apply this, let's apply this to the let's try apply this at color level. Maybe just copy this. I can copy this, go to the grid, close this, can make a bob here, attribute bob, make this grid really high, like 200 points, and then let's just add color here. Just paste that Voronoi, paste that, put that into the color, and you can see here's the pattern in geometry, which is the same thing. So it's basically generating 1 point at every cell. So, and you make it the frequency larger, it gets more points. You can see we're just looking at this, basically this area here. Then that area is still there, but we have more points. So at each center there's a point, basically, and from that point the cell becomes what it is, this Voronoi pattern here. So now if we scatter some points to the surface, let's scatter 10 points. So that's 10 points there. Just hide the grid. There's 10 points on that geometry. So we can do cells from each point around here. And one of the ways that you do that is you can use the shelf tools, but there is this Voronoi fracture tool here. So let's put that one in, which is the main ingredient here for the one that is here. Where is it? You'll be there, a shatter tool here. So it takes three things: a geometry to fracture, which is gonna be, let's say in this case, the grid. It takes points for Voronoi cells, and you can see this is talking about exactly what we just learned. when you see points for Voronoi cells, you're like, oh, I know exactly what that means, because at the center of each point, it is where the origin of that cell is gonna be. That's key information there. So now let's put that there. And the third one is optional SDF for depth sampling, and we don't actually need that right now, so let's just activate that. And there's gonna happen two things here, or a few things, but one of the things I wanted you to see is that the geometry looks really bad. Like there's more information on top of it, but we kind of see the cells there, and the that information that it's overlaid on top of is because it's trying to generate inside surface, but this is just flat. So let's not create the inside surface here and just creating like a 2D 2D version of this right now. Let's reduce the number of rows here so we can see the cells better now. And there's also a visualize pieces, which gives us this really nice way of visualizing that. There's also a triangulation that can be used for 2D or 3D stuff. In this case, it's just auto detecting, is detecting that this is 2D, which is okay. Let me just hide the wireframe, and you can see the cells there are pretty cool. Those are the cells. And if we see the points from this guy, let's see the points there. I can actually just let's copy some spheres to those points. Spheres, just to make this point really clear. You can copy, I can kind of see the cells here forming as well. You can see it's kind of like how the cells are looking in the grid. You can see if we go like that, you kind of see the same pattern there. So if we go from the top, let's see the top, you can kind of see that there is a pattern where the cells cross. Did not show the wireframe. Okay, so you can see this is kind of what the pattern looks in the result here. So this is what's happening. These points in the center of each cell grow until they collide and they make these cells, right? This is good information to know because we know how this is being generated. We merge these two. You see now there's the points at each center. It's the center of the cell. And one thing you should know is that this edge between the 2 points, so like this edge is shared by these 2 points, and this edge should be exactly the same distance from this point to this point. The same for this edge is the same distance for these 2 points. Just like that. All right, so if let me make these points better, more visible, like red. There we go. If we go and add more, color primitive, there we go. Okay, so if we go and add more points here, or less points, like 2 points, now we just have 1 partition there. We can move them around. You can see they are just fighting for that cell, for that geometry. 3 points, creating that. As we create more points, we are creating more cells. So if we want to manipulate the cells, we can do it. We can go here at this level and create select the point which is 2. Select one of those points and move it. You see I'm moving the cell there. But now they are, well, it's the same thing. Same things apply, right? But if I want to say, well, I want more cells here, you can move the points to that area. And this is something that other applications kind of show, and they're like, oh, look what you can do, interactive fracturing. And well, yeah, you can do that in Houdini as well. It's just a simple plane. It's really fast to calculate. So if I want all the fracturing in this side, I can do that. Can put the points there. There we go. So this is one way that you can do that and control those points. So now that we are in the subject of moving those points and place them in an area, we might want to scatter some points with something else. Like let's put a paint node. There's a lot of ways you can control this, but a paint node it's something that it's really common to do. Let me make this again really high dense, and I'm gonna just copy this, drag it here, and relative reference. They both stay the same. And so in this paint node, now I can paint some color. Let's paint some red. I really like red, as you can see. I don't want to select some points. I want to paint. So we have my brush. I'm gonna paint some paint here. I'm gonna add a few areas of paint. Let's say I want that. That's my areas of paint, and I can even actually smooth the paint. Smooth. Whoa, middle mouse. Smooth a little bit of this. All right, so now I'm gonna scatter points, but using that color. And so the density attribute here, just gonna select the color. So activating that, remove the density there. By I don't want them to relax. This just makes the points separate the points, but I don't want them for now. I want them to be where this paint is, and you can see they are getting there. Let's add more points. And they are actually not doing that. Because I always get this confused. Come on. Supposed to be working. Randomize for order. Density texture. Oh man, I always get this wrong with this new scatter. This new scatter sub. But I think it is. Yeah, it is because everywhere else that's also color. It's my fault. So I should have done first just make it black. Apply it to all. Let's just no, not paint. So it's just totally black now. And now I can paint some red or white, whatever color I want. I'm gonna paint some areas, smooth a little bit, then scatter. Now it's working. That was my fault. Since there's also white, also it's a color. So there was scattering points there. So now you can see that all the points are located in those areas. We don't need this edit now. Let's just delete that one. But now if we plug this, we have like what, 1,000 points. We plug this to the fracturing, you can see we're fracturing in those areas mainly. And this is how you can localize your fracturing in some different areas. So you can see that's pretty damn cool. And we can go back up here. Let me just reduce the amount of points because there's too much points right now. Let's put like 100. You can even go up and paint while you're washing this. See, painting, and it's updating. I want more cells here. Okay, let me paint some cells there. And it's pretty cool. You can see I'm painting there, scattering points there, and then fracturing there. Pretty damn cool. Let's see, let's add some more here. There we go. So you can kind of paint whatever you want. Let me just remove it again. Maybe add like a crack on the floor, and that's what I want my points. You can do that for sure. You can see that's where it's cracking there. All right, so that's something with a flat thing, right? Well, let me save this file. Yeah. Fracturing 10, well, whatever. So let's make a box now. Or actually, yeah, let's start with the box. And now, instead of just doing all that by hand, we can just select that one, go to the model shelf here, and we can say shatter, and it creates this setup for us, right? And there's one extra node here, but that extra node is because we want, if we want pieces inside the volume, so it's kind of just giving it volume. So let's see what's happening. So we have what we did before, but we're not in 3 dimensions, right? Again, same thing applies. You create a sphere and a copy, and copy this sphere to this point. You can see this is what's happening to the surface, right? This is what's happening to the surface. Those cells correspond to those spheres there. All right, so what's happening here, we take a box, and if we don't do this convert, we didn't do this before, we just did some points, and then we did that works as well, but we don't have points inside the geometry. We can use this exploded view node, to separate the pieces, which is pretty cool. We do have a solid object now because it's generating inside, but the function of this log, if we put it back in, it's generating points inside, and this we have too few points maybe here, but yeah, but this piece it's totally inside. Just a few, just a tiny piece outside, but what it's doing here is that it's generating this volume so we can scatter points inside the geometry. You can see they are not just on top of the box on the walls, but they are also inside. That's what it does, and this is a recommended way to do it, because if you have more points, like 50, some of these pieces will be just completely inside. Like all these pieces inside here, they wouldn't be there if you don't use this. All the pieces will go all the way to the edges, which is something that you might want to do again. So this is how you break some stuff here. The Voronoi fracture, it's pretty straightforward. There's not much stuff to know here, but there's a few things, pretty cool things, like adding interior detail. Like we saw the visualized pieces, which is pretty cool to visualize what you're doing. Cause the interior detail is just for the normals. Let's put it to smooth. You can see right now it doesn't make that big of a change, but if we see the point numbers, it should be adding more points there. You can see we are kind of separating each wall there, giving it more points at every corner. So this view cell point group, I think it's just for, I would use this just for visualize a piece. If I want to see one of the pieces, maybe piece 2, piece 5, let's see what's happening. You can just visualize one at a time. And this cut, we already saw it. If we put it to 2D, it's just gonna do like just a 2D projection of that, which is pretty useful for some stuff. Like for wood will be really useful. This thing, fracturing wood, and it looks pretty nice for maybe some motion graphic effects or something that's pretty spacey or something like that. And just 3D is the one that we're using, and out of the text, it's just the text is the surface as any thickness. You can offset the cut plane. You can see it's just giving like an offset between the pieces. If we remove this exploded view, or just see this, you can see the cut surface is just kind of eroding the surfaces. If you want to do like an effect like that, you can use this and add like a really nice effect to something getting forming or something like that. So the clustering, it's pretty useful when you have a bunch of pieces. So cluster pieces, you can see it kind of merges a few pieces. You can see this piece it's merged. It was one big chunk now. You can see this pink one, which is now big piece now, and it's pretty useful because sometimes pieces look too generatey, like they look too. Let me hide this window. I don't want to see you. There we go. Sometimes they look too computer generated, so it's nice to generate all these things clustering, so it gives a little bit more uniqueness to the pieces. All right, so what else here? And you have attributes to kind of see how much clustering you want. You can see now I have just 3 pieces there. If you want less clustering, you can just, again, you can use this for kind of an effect as well. You can see that should be really cool to do some kind of effect like that. Looks cool. All right, even if you're here, it looks better. All right, and clustering there. Interior detail, it's pretty cool. Let's reduce the amount of pieces to 10. So interior detail, if you enable that, you can see it's gonna add detail inside the pieces, which is pretty cool to give detail to the pieces in the broken areas. So let's you can see that it's adding detail inside. You can reduce the size to give it more detail, and the amplitude, all the known controls of noise. You can just use one piece here. See, I'm adding detail inside there. It's pretty cool. You can give it as much noise as you want, and change the type of noise, etc. It's pretty cool to add a really nice, and you can actually visualize the noise here, which also gives it a little bit nice cool gradient as well. And if we add that to all the pieces, just don't see this. You can see it looks pretty nice. With the interior detail, it looks like something has been broken. You can see they match inside. The pieces still kind of match together. If we undo this, they form and they can separate really cool. Dennis, will be better adding the interior detail via shaders? Well, it depends. Sometimes it's just simpler to add the detail here. If the detail is pretty complex and it's the object is pretty dense, you might be better adding detail in displacement, or you can kind of add a little bit of detail here and complement it with more displacement, so you kind of get the general shape with this and then add displacement on top of that. And it all depends on the amount of detail that you want and the amount of geometry that you are handling. So yeah, sometimes it's better to do it in shaders. Sometimes you can combine both. Sometimes you can just go for this, and it's all good. All right, so the groups here just generates groups for the different parts. You can see there's 2 groups generated, the inside and the outside. It just basically means the interior parts of the broken areas or the fractures. See, let's delete the inside. You can see there has no inside now. If we delete the outside, there's no I mean, if we delete the outside, is this, there's only the insides now, right? It just generates those two groups. You can call them whatever you want them. And the attributes is just if you want any more attributes, there's some more attributes available for the process that it's done inside here. Which I also, if you can see, this is blue, which means that if you double click here, this is just a tool made in Houdini. This tool was initially done by a user, and then it got integrated into Houdini and got a little bit better. And I think he got hired by Houdini, by side effects, to continue doing this. So there you go. If you create some really nice tools, side effects might give you a job. And you can see, if you go inside here, you can see everything, that it's how it is made, every step. If you see that you want, you can make this better, you might, I mean, you maybe should. All right, so, but there's nothing fun about this if we don't animate this, right? So let's just give it like that. Let's keep this, I'm gonna keep this example as that. I'm gonna go up. Let's hide these two guys. Bring our good friend Roberto. Why is that not an option? What? There you go. I was scared for a second. I was like, where's Roberto? So Roberto, here, we wanna make it into, crush it into pieces and crush it to the ground. That's a really popular thing to do in Houdini. So very so simple that that's why I want you guys to understand what's happening behind this, because if you know what's happening behind all this, you will be a better artist all around. So I just click this guy, I select this guy and click the shatter tool to create my initial setup. There it is. If I visualize the pieces, you can see there's some pieces that are kind of mixed with the Roberto there. So let's add more pieces, like 100 pieces there. And it's generated. I don't want to build them. Now I want to put Roberto, go up here and move it, rotate it a little bit, and just gonna leave it like that. And create a rigid body ground plane. Now Roberto, I'm gonna select it. I'm gonna create an RVD fracture object. You can also use a glue object, but in this case I'm going to use a fracture object because it's already fractured. So ask me what I want to do, fracture object or the new packed object, and it explains the difference here and how it is better to use packed object. So just use the packed object for now, and let's just hit play. And Roberto falls to the ground, and it just makes a bunch of a big mess on the ground. Oh, Roberto. So you can see this is pretty cool. This is, I'm pretty sure you all done this before. It's pretty simple. The good thing, if you remember, we talked about in the dynamics LearnDay that about this thing inside bullet. Let's go here and let's see the bullet solver. We're using bullet, and Roberto, it's a packed object. We allow a bunch of bullet data here. If we show the geometry here, the guide geometry, you can see all these pieces, all these Roberto pieces are convex holes. So the advantage of the Voronoi solution is that it doesn't create concave holes with any point. So the way the Voronoi solver works, it's always gonna work really nice with bullet. So this is one of the advantages of doing this. The collisions are gonna be pretty optimal, and they're gonna work pretty well with bullet. So it's just the nature of how the Voronoi function works, and this is pretty simple. pretty simple stuff. I guess we can just move on from this. And let's do another Roberto. Robert, oh, why is not working there? Roberto, come on, Roberto. Roberto 2. Let's put it over here. Save this scene. Hide this guy. I don't want to see this Roberto anymore. And let's make a new DOP network here, because it's gonna be Roberto DOP. And let's bring Roberto up again. Select Roberto, let's put it up. Select that Roberto DOP here. And let's add another ground plane. Should be inside here. It's not. Let's make Roberto just an RBD object here. And we're gonna add a ground plane. Oh, there we go. It's so Roberto, it's there like nobody's bothering him, but then gravity comes and it's gonna fall. So gravity, force, Roberto falls. This is just whatever, right? But you can make this Roberto breakable dynamically here, and there's a shelf tool for this actually. So we can actually just select Roberto, make breakable. It says select the RBD object, which is Roberto, already selected. Press enter, and that's it. If we go back here, you can see it just created this node. Basically, this thing is just it's checking if there's is there an RBD object. Yes, then create that node, and we can actually maybe go and see what the tool is doing. This is what it's doing. It's just importing some libraries and calling a library, but it goes and calls this. We don't know what it's doing inside there, but we will do a Python thing or hangout, and we will see more about this. But you can see all these tools are just basically all of them done in Python, and you can go there and pick and see what's actually happening and make your own tools. So it just creates this node here, which is a fracturing Voronoi fracture configure object here. And again, it's an HDA, so we can go inside and see what's happening here. So it's creating some stuff here, creating the object, adding fracture parameters, applying the data, making the fracture geometry. So it's basically just doing the same thing we were doing it at sub level. So now if we play this, something weird's happening. It's like, oh, why is Roberto breaking here? So now Roberto is breaking, and it's automatically breaking. We don't have to actually scatter points and do the fracturing stuff. It's just doing it by itself. And the amazing thing about it is that if we rotate Roberto, let's make it fall on his head. So now it's gonna start breaking from here. So you can see the breaking is totally different, and it's based on the impact. And the the arm fall off. Really cool. The arms and the legs are just fall down. So cool. It looks really amazing. So if you submit this simulation to me, if I was your supervisor, the first thing I'm gonna do is give it more substeps, because you can see it's kind of a jumping at the moment of impact. There's like a frame that it doesn't break, and that's because it's calculating there. You can see it there. It should be already colliding, and then it kind of breaks and pops. And I always solve that just by adding more substeps. Looks a little bit more natural instead of popping. So if I see that and you are on my team or something, I'm gonna tell you, do more substeps, dude. You can see it's not breaking now. It's not jumping. Just breaks at that frame specifically. So let's lower the substeps for now. And things that we can do here is, you can see it breaks when it falls, and then this thing all the whole body or the arms, they don't break. They just fall and they are okay. But what if we do want them to break? Well, we can change the maximum fractures here to maybe 2, and instead of fracturing just once, they're gonna fracture twice. So pieces that already fracture can fracture again. So you can see there's the first fracture there, and maybe when the arms fall, and there we go, that was a second fracture there, and the arms, I'm totally sure they're gonna break. Yeah, they broke when they fall to the ground. But anyway, that's different. The arms fall and they fracture as well. Again, you can see it pops when the second break comes there. So that could be again fixed with sub steps. Sometimes they don't. Because the solver has more opportunities to solve that. You can see that solved the breaking there. Again, if weird things are happening with your simulation, you might need more sub steps. And what by sub steps, you're just saying, you know what, solver, you have more steps to solve what's gonna happen and at the next frame. We already talked about this in the simulation and the dynamics webinar. So this is pretty cool that we can do that. And let's do it the fractures to 1, and you can control the impact here if you want to, how much of an impact you need for this object to break. If we put this really high, like 200, it might not break, or it might just break a little bit. All right, so it broke. Let's put it to 2000 to 3000. Let's see if that breaks it. And it's still breaking. You can see maybe the amount of impact we have in the spreadsheet. Let's see one of the pieces. It should be here. There's not there, sorry. That information should be somewhere here. I always lost this information. Forces, maybe. Force, handle position. Yeah, this is always hard to get that information. Come on, where are you? Fracture, solve parameters, geometry, length. No, can't find it. Can't find that information, sorry. I'm always looking around, and I think this should be here. Mass, orient, initial density, compute mass, angular velocity. It might be this. It's 31,000. I think that's too much. We can keep making this something really stupid, like 20,000 to 30,000. And then you can see it's not breaking anymore. It's just so you just might wanna see what amount of impact you need to for that to break. So if it's not breaking, maybe you need to lower this. And this is volume, and the fracture, it's for the amount of fracturing that it gets. The one thing I want to talk about here is the impact ratios. You can see now it's gonna break there at that frame, and you can see, let's see the frame that it actually breaks at is this, and you can see there's the impact, it's here, and the radius of this impact is gonna be from here, like make it like a sphere there. If I make this smaller, like 0.1, let's see how much it breaks now. you can see now it just broke this area here. So if you want to control the area where it breaks, this is the parameter to tweak. So if you're just like, oh, this is too small for the breaking, I want it to totally break completely, just raise it up, and it's gonna break more of the object at once. There we go. It's just the radius is just getting stupidly big, and it just breaks everything, which looks totally unnatural. Of course, we should have like some resistance absorbing the impact a little bit. So this is again same as the Voronoi, how much points you want per area, and the area it's defined kind of by this radius here. If you want more fractures, like 50 in that area, you're gonna have more points. You have more pieces, of course. You can see it. You can see it there. So it's basically the same as we did in subs, but it's dynamically being generated here. All right, and it shows fracture points. You can see the points and the point density, etc. Most of this is very similar to what we already saw. All right. So the only other thing I'm gonna say about this is, should I go with the glue? I don't know. Is there any questions right now? It's impossible to break an object that is already sitting in the ground. Well, it's not possible, but because the auto braking depends on velocity, so it should have an impact. If it's just sitting on the ground, there will be no impact information. But I guess you could, but it's gonna look weird. What I would do for that is just add a magnet force or something that triggers the explosion or the braking. There's somebody's telling me that there's an impact there. Let me just look around there, because the impact is important for this, but I always lose it. Oh, there's a filter here. I didn't even know. Impact. So there we go. Impact. There we go. There's the impact information here. Impact. There we go. Thank you. Thank you, Six Grilling? Something like that. And there's some impulse here. And position. I'm not sure if this is the actual data that I want. Let's see. There we go. The impulse. Yeah, this is the impulse data. It's the amount you need to break. So if this is bigger or smaller than the radius, the range here, it might not break or just totally kind of break. Cyril, oh, thank you, man. Yeah, you can just manage their impact yourself. If you are you can do a few things. If you don't want them to fall as mesh, you can just maybe change the mass of the object so it doesn't have much of an impact, or don't make it fall as high, or there's different things that you can do. And just remember that we are in the business of cheating, so I might have this object that it's seeing like it's falling all the way from here, but maybe midway through I replace it at this frame with another object that just falls like 2 frames, and then the impact is less. Or you can just maybe with Bex maybe control the impact data here. Let's see if the impact data, if the impact data is available here someplace. Where the point frames should be available somewhere. If we just know what the parameter it's called, we could just maybe use Bex and multiply the impact or multiply it down or up. So yeah, you can kind of control the impact, and there's also this tool for impacts that I've never used, but I think it just makes it invisible. So it's like that, make it visible. So I think, yeah, it's just an object that a solver that creates some geometry where the impacts are, I guess. And I don't see them. Impact, data, display geometry. I don't see anything displayed here. Distant threshold. But yeah, I'm pretty sure that if we go inside this tool, we can get how the impact data is. Oh, we can't go inside. Data and impact analysis. So interior surface, exterior surface. But yeah, you could. There's ways to control this stuff for sure. Let's remove this stuff, and I have this multi-solver that I don't want. Just put this guy here and this here. That should be, yeah, that's the way it was. So are there any more questions here? There is another way of fracturing geometry, and it's just with BDVs. So I might show you that pretty quick. And let's make another Roberto. Roberto 3. And we're gonna go inside this. And if we convert this to BDV, convert to BDV, make it a BDV. I know that's not what we need to do. BDV from polygons, sorry. BDV from polygons. Sorry for that. So we have this surface that is just like a volumetric representation of the surface, and we can if the BDV section here, there's a fracturing. The fracture requires an object. Let's do a grid. Let's do it here. Let's do a grid and connect it here in the second input. Now that's gonna cut Roberto there. You can see it's cut there. And now we just convert this back to polygons, convert BDB, and convert it to polygons. Now you can see it's cut, but the object looks pretty low res, and that's controlled by the amount of voxels here. 0.05. There we go. You can see that it's cutting there, and this way of cutting geometry is something other you can use. You can see this looks like stitches on Roberto, like the geometry is stitched together like pieces of cloth. So this is something that it might be even used for modeling stuff. So now you can see this. If we explode this, exploded view, you can see this is 2 pieces now. It's actually 3 pieces. The inside is there as well. Split fragment visualization pieces. You see it's 2 pieces. I think this is too small. You make it bigger. Let's see, is this big enough? Yeah, it's super big enough. So that's another way to I know, assemble. Let's make an assemble to separate the pieces, because this thing uses the piece attribute there to separate them. You can see that's being separated there, and the cuts are pretty cool. If you raise this more, you can even get pretty nice cuts for geometry that you might want to cut really smoothly, but it's gonna take a little bit of processing. Yeah, grid it's stupid because it's flat and it's not a volume. So That's why I'm left with something there, but we could delete that if that's what we wanted. We can use something else like a box, like a sphere. And this will really cut really cool the object. You can see it's pretty effective there. Let me just make it not so big. That, leave it a little smaller. And there we go, it cuts there. Cuts a few pieces of Roberto there. Exploded view works really fine. I don't want to see that. See that how it looks, and in some cases it looks pretty cool to actually fracture stuff in BDVs, because you have all these areas that are not straight as in the Voronoi method. So somebody wants to talk about glue. Yeah, we can talk about glue. So we have already a setup here in use. Have Roberto fall in there, and it's breaking. Actually, maybe better to use the other one, or make a new one, because it can give you this scene and you can see it different ways. Make a new Roberto, and I think this is gonna be Roberto 4. Roberto 4. All right. Yep. Hello, Cyril. Hello there again. So let's hide everything else. Let's just select these guys and hide them. Let's make a new dop, and let's call this glue dop. Let's hide it. Let's hide this as well. Make that the active one. So the glue, let's make Roberto shutter. Also, this break node creates like breaks. Let's try it. Breaks the object. You can see. Let's break that one. Select that. Break it. It's gonna create a geometry and just make a break node that it's not that efficient, but it's nice. It's using the I think it's using the cookie operation to cut. Let's go inside here and see for sure. You can go inside, and yes, it's using the cookie sub, so it's not that efficient, but it just breaks the geometry as well. If you need that to have a geometry that actually divides your other geometry. See. Is it? Yeah, it's breaking, but it's just not visible because of the. There we go. There we go. You can see it's breaking there, where they are intersecting, which is similar to what we did for BDVs. So Roberto, let's show his shading. We have nothing here. Let's make this. Let's shatter it, and we have. Let's add like 30 pieces. Good amount of pieces there. Visualize the pieces. All right, cool. So now we have this object. Make it a fracture object. Let's make it a glued object from here, and we are going to use again packed objects because that's pretty efficient. Now if it's not going to fall because there's nothing here at all, it's just a glue constraint and some stuff. Okay, so this, I'm gonna create this. Roberto. Oh, yeah, there's no gravity. There's no gravity here. And let's create a ground plane. So now this object, it's glued and it's not breaking. So it's basically literally glued together. So the pieces are glued together. And there's a few ways you can break those glue constraints. So there are constraints. And you can see if we go into Roberto, constraints are actually here. You can see that those are the constraints, the glue constraints that the simulation is using to keep those pieces together. Let's show the Roberto. And all right, yeah, you should be chatting. Don't worry about it. It's cool. So yeah, Cyril, there's most of these webinars have been basic stuff because we want to keep everyone at the same level and having reference for everyone else that it's starting and stuff like that. But they will be getting the level is gonna be going up and up as time goes and as I feel like I'm ready or you guys are ready to go to the next level or something like that. But yeah, there will be more advanced stuff, and I'm actually gonna do also pre-advanced stuff at the side. There's gonna be premium training that's gonna be for sale. So I'm already, maybe next week is gonna be the first list of that. So just stay tuned for that. So back to glues. So glue, these objects are glued together. They're not breaking. So there's a few ways we can break them. You can see here we have the break the glue thing, and it's being overridden by the SOPs right now, which is basically saying do whatever is in this geometry. If this is not moving or changing, you're not gonna break or anything like that. But you can actually disable this and delete this expression and say override with SOP. Nope, and start making some no, use it to transform. Say, wow, come on, it's breaking a little bit there. You can see it's starting to break there. You can see that piece is falling off, and the glue force, it's the strength is here. So if we just reduce the strength of the glue pieces, you see they just fall. And we put more strength. It was like what, 1,000. Let's put 500. You can see some pieces break now, but some don't, and they respond again to the impact and all this stuff. So you can see the head is staying together there. Some pieces break. The other way you can do this, which is pretty cool and pretty controllable, you can say this, go to this object, override by SOP. Yes, I want to override that by the SOP. And see, that's looking pretty weird there. It kind of stays there. So what we can do is actually, let's not add gravity for now. You can see it's just gonna stay there. But this is something that it's used something like in a build and you want to start breaking or something. And well, yeah, if you don't know how to build the glue constraint setup, there's no way to know how to build it. So if you use the shelf tool, you know what the tool needs. So that's why I keep using the shelf, because it gives you a very nice starting point. That's what I wanted to say. So now these pieces are just like geometry. You can see they're just points joined together. If you want to do something cool, like just let's delete some points here by points by bounding volume. Let's do a sphere. Let's make the sphere start growing, and pieces are gonna start falling. So let's make this start at 0, completely nothing. Let's keyframe that, and by 48, let's make this bigger to cover the whole thing. So I'm just deleting points here, and what this is gonna do is just gonna tell the simulation to start breaking those glue joints together. So let's rewind and play, and now they should be falling, but there's no gravity. Sorry, gravity. So now they start breaking the stupid me. Use object transform. What am I doing? Force. What am I? Okay. Something is wrong. Override by sub. Yes. This is the constraints. Oh, I need to. No, it is correct. Use object transform activation guide. I don't want. Yeah, this is kind of a hard setup because I don't want the other pieces to start falling, but they are falling all at the same time. So, a control breaking point. Yeah, cool. Yeah, connecting adjacent pieces is one of the ways you can create these points. You can create them different ways, but for this setup, what can I do? Maybe glue. Constrain something, or the thing is that I'm just, let's do something weird. Let's group objects by velocity. How was I doing that the other day? Yeah, I don't want to use Bex so much because geometry wrangle. Geometry wrangle. No, not wrangle. I don't want to use Bex as much, but I can do. Let's make the active property. Oh, man, I'm getting too deep into this. I didn't want it to make this too deep. So let's see. So I want to break these constraints like that, and the pieces should start falling. So there's some attribute here. Name. I'm just thinking if I should go and make this. So let's do it. Let's just, I'm gonna do a, what the hell? My other computer just turned on by itself. So what I'm gonna do is just make a multi-solver, whatever. Let's see if this works, because I wasn't ready for this. So let's connect the object here, connect the solver here. Let's do a subsolver first. And in the subsolver, I'm gonna say the geometry. I'm gonna add a group. I'm gonna group geometry by points and by a bounding box, bounding sphere actually, just like I did for the other one. And I'm going to, yeah, this is not in the right place. I'm gonna try to copy this expression, or yeah, from 1 to 48. I'm just gonna do it by hand. Yeah, that's what I'm doing. I'm gonna do in the subsolver way, but I didn't want to get this deep into the to this, because some people might be just confused about what's happening. So I'm gonna just animate this. I didn't add a keyframe there, keyframe, and keyframe. I'm not seeing the sphere. There it is. All right, I'm just gonna move it up by the same amount to Roberto. This put it here. Paste copied values. That should be paste copied values. Right? There we go. That should put it in the same place as the other one, but it's not big enough. I don't know why. Oh, maybe the other one wasn't. Yeah, it should be bigger. This is going all the way to 3.1. All right, sorry. So 3.1 here, 3.2 maybe. It's all right. All right, so what I'm gonna do with this group, I'm gonna call it pieces, whatever. And gonna add an attribute here. With Bex here, I can do this with a wrangle. I already got this deep, so I'm gonna just do it. So I'm gonna add an attribute active. Active is gonna be equal to 1. Let's see if I remember this correctly. I'm gonna not make this active. Active object should be here. Create static object. Now it's still breaking. Create static object. Why is that still falling? I'm creating one static object. Yeah. Creating. Don't solve this at the first frame. Read body solver. Gravity. We could put them in a group or something. Whatever. I just want these two set always. I think that's what I want. It's kind of working. But let's see. I think the value it's not. Let's make it an I. An integer value 1. So let's see if that works. It's not working. Or is it? I think it's working because they're starting to move. I don't think the gravity it's starting to move. They kind of it kind of move a little bit, but is this the other way around? I don't know why they're not working now. Should be working. With constraints, constraints should be okay. This should be okay. It is working, but I don't know why they aren't falling. They are kind of moving a little bit. You can see they're moving here. I don't know why aren't they falling. So what I'm doing basically, it's I don't know why this is not falling. Should be falling. Active is 1. Acting on points. Should be acting on points for sure. Solve a creation frame. Not sure why aren't they falling. Did I change something on the gravity? I didn't. It's affecting. Oh, I removed the gravity actually. My mistake there. So this is. Damn it! It's not working. Okay, well, I guess we're gonna have to leave this for another time because this is not working. I was trying to just make the pieces start to fall instead of just falling together, but because I need more time to figure this out because this shouldn't be creating an active object. Should be working actually. Let's see what we have here for I don't want this thing now. Oh, Houdini crashed. So fun. So fun. Alright, so that's basically the idea. I just need more time to get through that. So that's why I really wanted to get into that, because it is not as simple. Some stuff, it's just not simple. It's working. I'm missing something basic because the pieces start to move. Maybe there's too few pieces. Let me just make more pieces. 50. Maybe they might be stuck together. I'm not sure. I just made too much pieces. Yeah, Houdini crashing. That might be a sign to stop this recording. See, the pieces are starting to move, but I don't know why they aren't solving. Ah, I actually lost the setup that I had. All right, that's it. That's all for today. So maybe I'll just prepare something later and show you guys how it's done. But if you want to break some of those constraints, you can do it here instead of just doing. Let me just not animate this and just break a few of the constraints. Let's break this area over here, this side. We want those constraints to break. So now if we go here to the glue object, and see only that area is being broken. So you can control how you break those constraints with that geometry. Even if we turn Roberto around, like on his head, let's just turn this like this. Just breaking on this side that we remove those glue constraints. And all the other glue constraints are actually basically intact, but they are gonna still respond to impact. You can see it kind of broke a little bit in the head, but basically all these ones here just broke away. All right, are there any questions before I just call it quits for today? I think this was a really nice session. We learn about fracturing. We learn about constraints. We learn about, which basically glue, and we learn about the Voronoi formula, algorithm, how it works, and you now understand what's happening with this tool. You might be able to go there and tweak it, make it better, and you have simulations of constraints, of fracture geometry, how to fracture it, with impacts. So I think you're ready to do some damage. All right, cool. So no questions there, eh? All right, so that's gonna be it, guys. Thank you so much for being here. I really appreciate you guys being here, asking questions, and I'll see you guys in the next one, I guess. If you haven't subscribed, please subscribe to the channel. It's pretty important for me to see that the interest that you guys have, and please look around the channel. There's a lot of things there, a lot of tutorials, other webinars and stuff like that. And maybe next week I'm gonna release the first premium tutorial, which is gonna be pretty cool, advanced stuff, fire stuff. So what else do you want in a tutorial? Fire. That's pretty cool. Alright guys, thank you, muchas gracias, thank you for being here. I really appreciate it. You guys are amazing, and I'll see you guys later. Cheers.